what I'm going to explain you is something called relations and functions. So let's say I have a set A equals to 1, 2, 3, 4, 5.
Yep.
Now, how many elements it has?
Uh-huh.
It has got 5 elements, right? And these elements are the individual numbers 1, 2, 3, 4, and 5.
Mhm.
Now, let's say I have another set A1
Mhm.
and it has something, the elements are something like this 0, comma 1, 1, comma 2,
Mhm.
1, comma 4. I'm just randomly putting some.
Mhm.
Now, this is a set of coordinates. If you look at the first set A1, your individual elements were just numbers 1, 2, 3, 4, 5. Whereas in set A1, you have your elements as coordinates. So x, y, x, y, x, y, x, y. So when you have a set of coordinates, you call that set as a relation or relationship.
Mhm.
What is a relationship? Relationship between x and y.
Mhm.
Now, the x component of all of this. So what are my x values in each of the element
Mhm.
in this relationship? 0, 1, and I'll not repeat the duplicate 1 and 5.
Mhm.
So they are all x elements
Yep.
of the relationship.
Yep.
And what is the y? Y is 1, 2, 4, and 6.
Yep.
So in this scenario, in a relationship, when I separate out my x and y,
Mhm.
so what I eventually create is x values are called the domain
Mhm.
and y value is called the range.
Yep.
Domain and range,
Yep.
right? Making
Yep.
sense?
Yep.
All right. Now, domain and range.
Mhm.
So domain are all the x values, range are all the y values.
Mhm.
Now, if I write something like y equals to x plus 5, and I input x equals to 1, what is the value of y do I get? I get y equals to 1 plus 6. So x is the input and y is the output.
Mhm.
So my domain is always the x values or the input in general,
Mhm.
and y value is the output.
Mhm.
However, this relationship in this scenario
Mhm.
is called a function.
Mhm.
So number one, relation can have any set of x and y values. It is not particularly driven by a rule.
Okay.
Whereas when your x and y's when your input output are tied to a rule,
Mhm.
then that relation is called a function.
Yep.
So let's understand function in a bit more uh, detail, right?
Mhm.
Now, let's say you have a rule y equals to x plus y.
Mhm.
So think like this, that you have a box where that rule is sitting inside. And this box is what I call it as a function.
Mhm.
This function takes an input,
Mhm.
and that input is the x,
Mhm.
and I call this as my domain.
Mhm.
And it spits out an output,
Mhm.
which is the y,
Mhm.
and I call it as its range.
Mhm.
So what eventually I'm trying to say is that function is a box, a black box.
Mhm.
Inside the black box, there is a rule written
Mhm.
which accepts an input,
Mhm.
spits an output.
Mhm.
So if I say, let's say I input x equals to 5.
Mhm.
So 5 goes here and spits out 10.
Mhm.
Y equals to 10. I say x equals to 1. Y is 6. So this box is nothing but a diagrammatic representation of a function.
Mhm.
And in function notation, I can write this box as f of x. A function that accepts x as input and spits out an output. So if my function in this scenario was x plus 5, so when I say x equals to 5, the final value is 5 plus 5, 10, which is the y. So this is the function notation. So now on, we will not write y equals to x plus 5. We will write it as f of x equals to x plus 5. We'll say now this y is nothing but it is a function that accepts x as an input
Mhm.
and spits out y as an output.
Mhm.
So this is in general the distinction between a relation. So relation does not have a rule.
Mhm.
Could be, could not be, right?
Yep.
But function will have a rule and it has to adhere to certain more sort of regulations,
Yep.
right?
Yep.
So this is in a very, very simplistic form what a function is, right? And how we represent a regular algebraic equation in the
Mhm.
form of function notation. Is that clear?
Yep.
All right, cool.